We have two fractions. Which one is larger? First, compare the denominators. This denominator is larger, so we break this fraction's denominator and numerator into parts. We use the other fraction's denominator and numerator as the reference. The denominator is 57 plus 6. The numerator is 11 plus 3. Now we see two fractions. Instead of comparing 11 over 57 to 14 over 63, we compare it to 3 over 6. Since twice 11 is 22, this fraction is less than 1/2. But this one is exactly 1/2. This fraction is larger, and this comparison directly applies to the original fractions. So 14 over 63 is larger. Let's go through another example. This denominator is larger. We split this fraction's denominator and numerator. The denominator is 253 plus 102. The numerator is 113 plus 53. Now we see two fractions. Let's compare them. Twice 113 is 226. So this fraction is less than 1/2. Twice 53 is 106. So this fraction is greater than 1/2. This fraction is larger. So this fraction is larger. This method is simple and effective because it breaks down complex fraction comparisons into smaller, more manageable steps. Now, let's explore why it works. The fraction 3 over 4 represents the ratio 3 to 4. A fraction is a ratio, so it can represent the slope of a straight line. If a fraction is larger, its ratio or slope is also larger, so we can compare fractions by comparing slopes. 11 over 57 represents the slope of this line. The point 57, 11 is on this line. Similarly, 14 over 63 represents the slope of another line, passing through 63, 14. Comparing two fractions is the same as comparing these two slopes. To get from this point to this point, we move plus 6 units along the x-axis and plus 3 units along the y-axis. This slope is 3 over 6, 1/2. If 1/2 were equal to 11 over 57, this point would be on this line. In that case, both the slopes would be the same, meaning the fractions are equal. But if 1/2 were greater than 11 over 57, the point would be above this line. That would mean that this slope is larger than this slope, making this fraction larger. On the other hand, if 1/2 were smaller than 11 over 57, the point would be below this line. That would mean this slope is smaller than this slope, making this fraction smaller. So the magnitude comparison of these two fractions follows the same pattern as the original fractions. By comparing these fractions, we can determine the original fractions. That's why splitting the fraction helps in comparing fractions. This method can be applied to many different cases. Let's try these fractions. 277 is greater than 37. Split this fraction. But the denominator and numerator are still large. In this case, we think of 37 being added multiple times. 37 times 7 is 259. So 277 is 259 plus 18. When splitting 116, we also multiply 14 by 7, which is 98. So 116 is 98 plus 18. Now we have two fractions. This fraction equals 1, so it must be larger than the other. Thus, this fraction is larger. Let's try another example. We split this fraction with the larger denominator. 74 is 67 plus 7. 23 is 21 plus 2. We compare these two fractions, but it's still unclear which one is larger. In such cases, we repeat the splitting process. Split this fraction. 67 is 7 times 9 plus 4. 21 is 2 times 9 plus 3. We compare these fractions. This one is less than 1/2, so 3 over 4 is larger. Thus, 21 over 67 is larger than 23 over 74. When comparing fractions, split the fractions instead of cross multiplications.